All right, our problem. Okay, the following object contains 23 blue cubes and 4 yellow cubes. Each of those little cubes has a volume of 8 centimeters cubed. So the problem is, what is going to be the total surface area of the object if we remove the yellow cubes? So if we totally get rid of the yellow cubes, what's our final surface area? So this is a grade 9 problem from a grade 9 exam. And if I were one of my own students, I would think, okay, I see geometry. There's shapes and there's numbers, and it's kind of giving me an idea of a change that's going to happen, so I should draw a diagram. And that's most of the time what I would encourage my students to do in this situation. But as you start to draw this new diagram with the yellow cubes removed, you'll start to see it's a bit tricky to draw or to interpret what's going on. I even tried to draw one myself and came up with this. And I did a lot of white. You can see my whiting outlines here. I even missed an entire cube in the center. Actually trying to draw this is a bit difficult, like envisioning what lines am I supposed to draw or which ones am I supposed to not draw. And then, is it easier to see the surface area after I drew this? Not really. Especially if I added in that one middle cube I forgot to draw, it would be pretty hard to see what I'm supposed to be counting here for surface area. So what can we do that's a different approach? So let's look back at our original diagram. I like this diagram. So cubes have 6 faces. Looking at our yellow cubes here that we're removing, we can see 2 of the yellow faces on each one, but there are 4 more that are hidden. So the 4 that are hidden there are sharing faces with the blue cubes there. So when we remove the 4 yellow cubes, okay, each cube, when we remove it, we're removing 2 faces from our total surface area there, but we're also adding 4 more because of those 4 hidden ones that we're now exposing. So we're exposing those inner 4, but we're taking the 2 top ones away. So overall, every time we remove a yellow cube, we are increasing the surface area by 2. So when we remove 4 yellow cubes, we're increasing the total surface area by 8 units, 8 unit faces. Okay, so now we have to think, okay, we're increasing it by 8 unit faces. Let's go back and think about what's a unit face worth. So back to our original problem, looks a little blurry, but we can see it. It says each cube has a volume of 8 centimeters cubed. So the cube root of 8 is 2, which means the side length of one of those little cubes is 2. And 2 times 2 is 4. So each of those faces, the little faces here, is worth 4 centimeters squared. So we have 8 extra faces now that we've removed the yellow cubes. And 8 times 4 is 32. So we've gained 32 centimeters squared when we remove those yellow cubes. So what were we starting with in the first place? We have to think about what was the original surface area. So we had 6 sides times 9 of our unit faces, and we figured out that each unit face was 4. So we started out with 216 centimeters squared. Then when we add our 32, we end up with 248 centimeters squared. So that's our total surface area after we remove those cubes. And my sources here, I have 2006 Alberta PAT, but these questions are pretty good, so I don't mind that it's an older question. And I also used Prezi to make this video. Thank you.